This paper is Why AI is Harder Than We Think, and it's written by Professor Melanie Mitchell of Santa Fe Institute. So she argues that in the field of AI, that is much harder than we think, and this has always been noticed in the periods of optimistic predictions and massive advancements, which she calls AI spring, and then followed by AI winter, which is actually the period of disappointments and loss of confidence and reduced funding, which makes AI much harder than we think and than we expected. And this is a this is boils to the fact that we have a limited understanding of the nature and complexity of intelligence. And so there are four fallacies that she mentioned, four fallacies in common assumptions made by AI researchers, which leads to overconfident predictions about the field. And so she concludes her writing by discussing the open questions spurred by these fallacies, including the age-old challenge of imbuing machines with human-like common sense. So the four fallacies. So she spoke about in the introduction. She spoke about the predictions they made in 2020 that, for example, in the self-driving cars, that is going to be the year for the self-driving cars. But all these assumptions, promises have not been achieved. And once we hit at that point, we come to the AI winter. So, for example, look at what Drew McDermott said. He said that perhaps our expectations are too high and this will eventually result in disaster. So suppose that 5 years from now, funding collapses miserably as autonomous vehicles fail to roll. Every startup company fails and there is a big backlash so that you can't get money for anything connected with AI. Everybody hurriedly changes the names of their research projects to something else. The condition is called the AI winter. So these are the ups and downs in the fields, and she emphasizes that this is as a result of a lack or a limited understanding of intelligence, the springs and the winters. So here we find the fallacies. But before we just talk about the fallacies, let us look at this area. Okay, even in spite of the optimism, it didn't take long for the cracks to appear in deep learning faculty of intelligence. I'm actually reading here from here. And this is because those systems are susceptible to shortcut learning. Now, ordinarily, how we learn is that we abstract ideas and then we make abstractions from what we learn, and then we take those abstractions and then apply it to new fields. But that is not how the machines, she argues, learn. That the machines actually learn through shortcut learning, and she explained what that shortcut learning is. It's learning statistical associations in the training data that allow the machine to produce correct answers. The answers are actually correct, but sometimes for the wrong reasons. So they may not be the thing we expect the machines to learn. They will learn other things that are correlated to that. And so the actual answers, true, it is correct, but they are coming from the wrong reasons. So let us move to the fallacies. So the first fallacy is that the narrow intelligence is on a continuing general intelligence. So if there is a little progress made in AI, so we think that we have made the very first steps towards a more general AI. But this is not true, because it's actually a fallacy. And she said that it's a first step fallacy. I think it is in this area where she spoke about it being the first step fallacy. So the philosopher Hubert Dreyfus now spoke about it, that is the first step fallacy is the claim that ever since our first work on computer intelligence, we have been inching along a continuum at the end of which is AI, so that any improvement in our programs, no matter how trivial, counts as progress. So he now made the analogy of made analogy, yes, quote analogy made by his brother, engineer Stuart Jeffries. So it's like claiming that the first monkey that climbed the tree was making progress towards landing on the moon. So it appears as if he's making progress, but it's actually limited progress. I don't know how far the progress is, whether it is really as much as we expect it to be, or whether will you count that just climbing the trees is actually a progress when compared to the long distance you're supposed to go. Well, she has a point in what she's saying, but the real obstacle actually in this area of AI has always been, according to the researchers, the problem of the common sense. So, but she said she's going to speak about it in the later part of this work. Then the second fallacy is that the easy things are easy and hard things are hard. So, for the fact that things are easy, we fall into the fallacy of thinking that they are easy, and then that the hard things are hard. But actually, the converse is the truth. Easy things are actually hard. So the things that are very easy for us, when it comes to the point of perception and mobility, they are much difficult for machines. So, for example, I think it puts this area. So look at what the roboticist said about this. He said that it's comparatively easy to make computers exhibit adult level performance and intelligence. The things that are actually difficult for us, it's very easy to make machines to do that on intelligent tests or playing checkers, but it's much difficult or impossible to give them the skills of a 1-year-old when it comes to perception and mobility. So the area of perception and mobility, which is just like a common thing for us, is much difficult for machines. And so no matter how much we try to push it, we have not yet come to that point. And that is where, when we give machines those tasks, they become brittle. They may not be able to handle the problems, and so they cannot be able to generalize. So we are actually underestimating the complexity of the unconscious perception and thought. Things about perception, thought, intuition, machines have not yet reached that level. It's very complex for machines. And so the brain, we are unconscious. They look at the emphasis again on that area, that we are very unconscious of the complexity of our own thought processes, because it's easy for us to just think and just give birth, produce an idea or a concept. We think that is much easy, but we are actually unconscious of the complexity, so we take the complexity for granted. So this Hans Moravec continues in explanation of this thought process of this. He now said that encoded in the large, highly evolved sensory and motor portions of the human brain is a billion years of experience about the nature of the world and how to survive it. The deliberate process we call reasoning is, I believe, the tiniest veneer of human thought, and effective only because it is supported by this much older and much more powerful, though usually unconscious, sensory motor knowledge. We all prodigious Olympians in perception and motor area. So good that we make difficult things look easy. More Cecilia, I'm having making notes. In general, we are least aware of what our minds do best. So that is for the second fallacy. The third fallacy speaks about the law of wishful mnemonics. So we wish that the machines will have those abilities which we human beings have, and so we tend to give them those same names. So for example, we may name our programs or algorithms words like understand or goal. Words like understand or goal. So we now talk, does it really understand? Or does it really have goals like the way human beings have goals? So he said a major source of simple-mindedness in AI programs is use of mnemonics, like understand of goals, to refer to programs' data structures. So if a researcher calls the main loop of his program understand, he is, until proven nonsense, merely begging the question. He may mislead a lot of people, most prominently himself. What he should do instead is to refer to this main loop as GO. Don't name it in mnemonics, name it another thing, to see whether the machine really understands, and see if he can convince himself or anyone else that GOO3 implements some part of understanding. Many instructive examples of wishful mnemonics by AI should come to mind once you see the point. So this is the lore of wishful mnemonics. So it continues. See the words they use. If you come here in this area, you talk about you read. They tell you that you read. They will tell you that it understands. They tell you that it thinks. So you may argue that it's just anthropomorphic terms. It simply is used as shorthand, but it may deceive people into thinking that they really understand the way human beings do, and that is actually a fallacy. So she now came and spoke towards the ending part that the benchmarks. So, for example, the benchmarks we talk about the data sets, which are like the benchmarks. The benchmarks test only very limited versions of these abilities. Moreover, many of these benchmarks allow machine to learn shortcuts, as she has described. Statistical correlations that machines can exploit to achieve high performance on tests without learning the actual skill being tested. So while machines can outperform human beings in this particular benchmark, AI systems are still far from matching the more general human abilities we associate with these benchmarks. So that is that. The last one is that the fallacy that intelligence, fallacy 4, is all in the brain. So it comes from thinking that the brain is a model um, of computer, it's a kind of computer. Why the reverse should be the true that computer models from the brain. But we now think that the brain is a model of computer, so that the brain is like you put in inputs and gives us output. And so if we think in that direction, so we tend to think about pure intelligence without the need for emotions and sensitivities. And that is where the fallacy comes in. So if the brain is just like a computer, you see, the common assumption is to just to bring as much scale up the machines to be able to increase its functionality and its capacity. So the assumption that intelligence is all in the brain has led to speculation that to achieve human level AI, you simply need to scale up machines to match the brain's computing capacity, and then develop the appropriate software for this brain machine hardware. And this is actually a fallacy because most of the research points that there is the embodied cognition. It's not just only the intelligence devoid of the emotions, that the way the cognition of human being works both with the cognition and with the emotions from the point of the researches that have moved on by cognitive scientists. So 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 the way we learn through the body. It is not separate from it. So the thought experiments proposed by Bosom and Rossi seem to assume that an AI system could be super intelligent without any basic human-like common sense. Yet, I'm reading actually from this place, from this last paragraph. Yet, while seamlessly preserving the speed, precision, and programmability of a computer, but these speculations about superhuman AI are plagued by flawed intuitions about the nature of intelligence, and that has always been the problem, having a proper understanding of the human intelligence. Nothing in our knowledge of psychology or neuroscience supports the possibility that pure rationality is separable from the emotions and cultural biases that shape our cognition and objectives. Instead, what we've learned from research and embodied conclusions is that human intelligence seems to be a strongly integrated system with closely interconnected attributes, including emotions, desires, a strong sense of selfhood and autonomy, and a common sense understanding of the world. It's not at all clear that these attributes can be separated. So these are the 4 fallacies. So she now gives, so what are we going to do about this? So these fallacies raise several questions for the AI researchers, as she said. So she speak about how can we access actual progress towards general or human level AI? How can we access the difficulty of a particular domain for AI as compared with humans? how much difficult it is. How should we describe the actual abilities of AI systems to start fooling ourselves and others with useful mnemonics, the area of mnemonics? To what extent can the various dimensions of human cognition, including cognitive biases, emotions, and objectives and embodiment, be disentangled? How can we improve our intuitions about what intelligence is? So these are the questions she asks. And central to answering these questions is the notion of common sense, which has which has been neglected much in, though there are some persons working towards that area, but it has not really been considered enough to be integrated into artificial intelligence. Once that is solved, it will be easy to unlock the answers to these questions. So the notion of common sense is one aspect of intelligence that has recently been driving collaborations between AI researchers and cognitive scientists from several other disciplines, particularly cognitive development. So there has been the interest to give human common sense to machines, but it has not been solved. So this is like actually a cutting edge or a frontier, the current frontier in AI research. There was a place I read, I can't remember, where a company is investing to see how they can input common sense into machines, and they invested a lot of money in that. I actually wanted to highlight it. Actually, this was the question, the approach recommended by Alan Turing in his paper, 1950 paper, introduced the Turing test. He said instead of trying to produce a program that simulates the adult mind, one rather try to produce one which simulates the child's. So if we try to tackle the problem of common sense, we can move further in our advancement, according to our argument, towards a more robust um, AI. So she spoke about the alchemy that we have now. What we are doing now is more of like an alchemy, mixing a lot of things that we have not developed a theory of or a specific understanding of artificial intelligence. So it ended with this quote by Eric Horvitz, the director of Microsoft Research. So he spoke concerning this, saying that right now what we are doing is not a science but a kind of alchemy. So in order to understand the nature of true progress in AI, and in particular why it is harder than we think, we need to move from alchemy to developing a scientific understanding of intelligence. So once we come that, having an understanding, a scientific understanding of intelligence, and also understanding the notion of common sense and integrating that into our problems concerning artificial intelligence, we're going to make much progress. It's a very beautiful paper, and it requires much reflection and thought to help us to also advance more, make AI as easier than we expected, so that it will not be as hard as it is. So that is how it actually ends. Thank you very much. Yeah.